Alright folks, Sega Sonic fan back. One more SlimX iRiver video here. For those that don't know, I mentioned in my previous video, this was a popular, or semi-popular, MP3 CD player in the early 2000s. I got mine in 2002 or 2003, and it was a big deal. These are great players. They came in a huge box full of accessories. iRiver at the time was a competitor of the iPod and Apple, and in my opinion, they've always made better quality products with higher audio fidelity. This was at the height of the MP3 CD, which was a short-lived phenomenon where you could put MP3s on a CD before hard drive portable players were the thing. This one also played Windows Media Files, if anybody remembers WMA files, and had an FM tuner. And was very, very thin. It's one of the thinnest CD players ever made. I'm happy to report that I just repaired my player. I had a few of them I've been working on, and usually what happens is the lasers just die in them. And in the case of a couple models, that was the situation. However, I had one model that was missing audio in one channel. And so I couldn't figure out why that was. You know, somebody, it might have been me actually, back in the day, I might have shot some voltage through it or something stupid. And it blew out one of the audio channels. So I thought I'd make a quick video because I did repair it, and it wasn't, you know, it was kind of an intermediate repair, and I thought it was really an interesting repair, so I thought I'd make a quick video on it. I covered some of the stuff in my last video. I'm going to go ahead and shut this off. Super glad to have this fully working. I've now repaired 2 of them, actually, and so I'm a happy camper. But let's go over what happens if you have like a dead audio channel. What do you look for? How do you repair something like that? Well, the first thing you want to do is find, obviously, your output jack. This is your line out jack, and then here is your stereo out jack. This goes to a proprietary plug that works with their special remote, which is a really cool feature, in my opinion. But you want to look for those outputs, and we'll see here there's like HR, so that's probably going to be the headphone right. It's labeled there. Some nice labeling here. Here's your antenna. Here's a left out L, and here's or line out L and line out R, so those are 2 good points to test from. And you can grab a ground from almost anywhere. I think there's one over here. Here's an analog ground that's really easy, not near anything. And you can probe those points with an oscilloscope, even a multimeter can work, and just see if you're getting a fluctuation in voltage. Usually when an audio signal dies, it'll be logic high or logic low. A lot of times it'll just be held to ground. Sometimes it'll be floating, but you won't get a fluctuation in voltage either way. So in measuring this, I believe it was the right channel that was completely dead. And so then you kind of want to look around and see, well, what could fail on the analog side of things? Sometimes you'll find there'll be a small ferrite bead inductor in the path of the audio signal. And you can go searching around this tiny board, these tiny parts, for that ferrite bead inductor or for an output capacitor. What I find is often easier is finding a large chip that would look like an op-amp stage, which would amplify the line output. And so in this case, this is a really obvious contender because it's one of the only SOIC packages. And one of the only reasons you're going to have an SOIC package on a portable board this small is if you're going to be doing a hi-fi op-amp stage, or if you're going to be doing a DC to DC converter. In this case, there's no power circuitry anywhere near here. It's near the output jack. So a little bit of research unveiled that this is in fact an op-amp. I also looked up this chip, which is, I think it's like LW052A or something like that. I mentioned it in the other video. We could zoom in. Can we zoom in on this? Oh, sweet. Yeah, LW052A. I was right. So that chip is a multiplexer. And that takes signals from, you know, switches. A multiplexer just switches signals. In this case, it's an analog multiplexer. This here is actually a radio tuner, which I thought was built into the remote, but it's not. This is your full radio tuner, and there's some parts on the other side. Some of the coils are always a dead giveaway for a radio tuner circuit. But here's your op-amp, here's a multiplexer, and then a little more research unveiled that this too is an op-amp. So I measured all those analog stages first. The multiplexer, you want to measure the commons on the multiplexer. In this case, it was pin 3 and pin 13. And then your op-amps usually going to be pin 1 and pin 7. You want to measure those and see if you get any output, any audio output, because that'll tell you if there's a break in the chain somewhere. You know, if there's a dead capacitor or some other passive part, or even the op-amp is bad. And then you can check the inputs for the op-amp, of course, as well. So all of that research unveiled that these were fine. This chip was fine. This chip was fine. This op amp apparently fine. And then there's another op amp on the other side over here, which is the same type as this, which also appeared to be fine. So that kind of more and more led me to believe that the problem was the output stage from the DAC, from the digital to audio converter, which is a bigger problem. And, you know, kind of concerning because I don't know where the DAC stage is coming from, if it was a standalone DAC or if it's something from the big MCU here, one of these big MCUs. And if it's one of these big MCUs, you could have custom programming that isn't compatible with different boards that I have that I'm pulling parts from, and things get decidedly more complex. Fortunately, for me and for the time period, this board actually uses, and you can see it here, this chip right here. This is a custom standalone DAC, which is really cool because with audio, it's nice to have stuff separate and not you know, all integrated into one chip where there's more chances for interference. So it actually uses this chip, which is the CS43L42 -KZ in this case. I don't think the KZ is very important, but it uses this chip right here, and it turns out kind of interesting. This is a pretty nice hi-fi chip. It's 24-bit conversion, 96 kilohertz. It actually not only is a DAC, it actually has a headphone output and a line output. So it's a pretty nice integrated audio chip. And I was impressed with the specs. I've always been impressed with the sound fidelity of these players, and I'm starting to think a lot of it has to do with this chip. A little bit of research unveiled that pins 23 and 22, I believe. So it's a 24-pin TSSOP chip. So 23 and 22, these two pins are the line outputs. And then pins 21 and pin 16 are headphone outputs. Interesting thing that I found out as soon as I desoldered this thing, because I did measure at 21 and 22, and I found a discrepancy. I found that one of them was outputting audio and the other pin was not, which meant either one of two things. Either this chip is bad, or it's feeding to an op amp stage that's bad and is shorting the output. I didn't really think the op amps were bad. I felt that was more unlikely, and that more likely than not, there was a voltage spike on the input and that this chip was bad. So interesting thing to note, though, is when you look at my board where I took the chip out of, this donor board here, you'll notice that, here we go, pin 21, which is this pin right here, 24, 23, 22, 21 is not connected, and neither is 16, which is this pin right here next to the ground plane, which is very interesting. They're not actually using the headphone output from that chip. I wonder why that is, because you actually could really benefit from dual outputs since this has dual outputs. There's a line out and a headphone output here. My guess is that iRiver didn't like the fidelity of the headphone output, and maybe there was too much, you know, THD or something like that, total harmonic distortion. Who knows? Interesting, though. I think it's very interesting. They decided to split the line level output than use the headphone output at all. So in my case, I actually could have, if I really wanted to, I could have hacked those. I could have hacked my player if I didn't have a donor board and pulled audio from pins 16 and 21, fed them through the capacitors that are in the data sheet. You can find a data sheet for this chip. And then I would have actually had working audio output that way, which is pretty cool. Fortunately, though, I had a donor board, so I was actually able to desolder this and solder in a new one. There's the old broken one, and now it works. Works like a charm. This laser is fully working. Everything about this unit is fully working now. I'm very happy with it. So, yeah, I guess that's it for this video. A little bit of old CD player reverse engineering. I thought it was a nice rundown, nice little project to learn a little bit more about DACs and analog stages, how things fail, what to troubleshoot. And repair a player that's maybe not worth a lot of money, but to me is really, really nice and fun to work with. So that's all for this video. Support iRiver. They're still around doing other stuff, hi-fi audio. Much better than Apple. Much, much better. Good high fidelity. It's prosumer. Prosumer. So it's not like your $1,000, you know, stuff. But for anything sub $200 range, these players are great. So yeah, I gave some love to iRiver products. I think they're good stuff. I've always liked them. And a little bit of nostalgia working on this thing too. That's all for this video. This is Sega Sonic Fan, signing out.